Dear students, today we will learn about reliability design. So it is under the dynamic programming solving techniques. Reliability design. What is it? So here now I am taking the class in online. Okay. So what are the problem for facing failure for this online classes? So proper internet connection and backup, battery backup, and my system will work properly. Software updation. Suppose my battery is down immediately, then I cannot able to take the lecture. Okay, my software is fault. That time also I cannot able to take that lecture. My internet is slow. Signal. It is also problem for not handling the classes properly. So goes for failure rate is more. So instead of that, if I have good software update, okay, and I have a new battery, and instead of one internet connection, as I have more than one internet connection, in case my mobile network Wi-Fi connection is failed, I will use my Wi-Fi networks. Okay, like that. If I have more than one alternative solutions for the same problem, if this problem will occur one, so I will switch over to the next one and I will use a class more effectively. Reliability, reliable. Okay, so how to design like that? So that is for reliability design. Okay, so here, suppose in system, this is device 1, device 2, up to n number of devices. These devices are connected parallelly. That is seriously. The output of device 1 is used the input to the next device D2. And next device D2 output is used to the next device. Like that up to n number of device. Okay. So here, suppose in case device 2 is failure, what happened? Device 2 is failure. So you cannot process the sequence. The output, the process is stopped. Okay. So that time crashes is happen. Okay. So multiple devices are connected seriously, and the output of one device given input to the next device. If any one of the inverter in any one device is failure, crashes, then the operation is failure. Okay. So that time it is not a reliable system. So each device we have to calculate the reliability R1. For device D1, the reliability R1. For device D2, the reliability R2. For device DN, the reliability is RN. Okay. So what it happens? So instead of using a single device, okay, parallelly we are using more than one number of devices. That is the device 1. If it is that operation we are copied at the same time in D1 and another one device also. Suppose in case D1 is failure, we may be used for the next D1 device. Okay. So multiple copies we are making, and whenever if it is one device is failed, we are using the another same copy of the device. Okay. So now, how many devices we are used in one device? D2, how many devices we have to use? And D3, how many devices we are going to use? That is the problem. Reliability of how many devices we are used in each devices. That is the reliability of device. That is the problem we are going to solve here. Okay. Suppose in first location one, we may be used for 3 devices. Another disk we may be used 3 devices. Another disk may be used 2 devices. So how many devices we are using in each single device? That is we are going to calculate in reliability design. Okay. So what is that? It is the ability of machine or apparatus system constantly perform its intended without any error or required function mission on demand without any problem failure. That is for reliability. You already know. So that reliability design is used using dynamic programming concept. We are going to solve in a multiplicative optimization function. Okay. So here I said no number of devices. So the problem is design the system with a composed of several devices connected in series. Suppose the first system or be the reliability of this device D1. Then we say that a device I is function or is the probability where we giving the probability that is device I and it works function properly. Okay, that is there for a single device. Suppose if you have a more number of system, more number of devices, so the reliability of the entire system is pi into Ri. This is the problem. Pi into Ri. So this is for a single system. Then the entire system we say that pi into Ri. Okay. So here Ri is very close to once, that is a single device reliability. So the system may not be very good. So that overall reliability is pi into Ri. So here it shows that how that parallel connections we are made. So here there is the device 1, device 2 up to a number of devices connected seriously, and each device we have make a copy of another one. Okay, that is stage 1. So D2 we are making another copy, D3 we are making another copy up to Dn. So in each stage, how many devices, reliable devices we need to take? That is reliability problem. That problem we are going to solve by using that optimization function, dynamic optimization function. So multiple copies of same devices are connected, and we are using that name is called switching circuits. This is switching circuit that determines which type of devices in any group are functioning properly, and then make use of one such device at stage. Okay. So I said no, the problem is we have to use the device duplication, maximize the reliability. Whenever once one device is failed, we will take the another one device. So we have to maximize the reliability, can be carried out under the cost constraint, under the cost constraint. So the cost of that each device, if you are using 3 devices, the overall cost is something, and each device cost is separate. Okay. Each unit having a separate cost. So that is CI. CI is the each unit of device cost. I means it is the system first one. Okay. C is the maximum allowable cost of the system. So we wish to solve the following the optimization problem. That is, we are using the formulas called phi 1 less than or equal to I less than or equal to n into phi I IA. It is subject to summation 1 less than or equal to I less than or equal to n Ci Mi less than or equal to C, where Mi greater than equal to 1. Okay. For that, each device I1 to n. 1 less than or equal to I less than or equal to n. So this formula is used for dynamic programming solution, can be obtained in manner so that it is used for maps of problem also. Okay, let's see about how we are using that, how to solve the dynamic methods, reliability design. So I said, no, this is number of devices connected seriously. So here the disk R1 reliability is R1, disk R2 reliability is R2, and D3 reliability is D3, and DN is RN. Okay, so the reliability of the function is pi R1, the first disk. The reliability, suppose R1 is 0.99. 0.99. And we have the n number of devices. How many number of devices? N equal to 10. Okay, so n devices are set in series. So I1 less than equal to I less than equal to 10. So the overall reliability of the whole system is, okay, pi Ri. That is 0.904. Okay, that is for single disk reliability. So if we have duplicated the devices at each stage, then the reliability of the system may be increased. Okay, so can be said multiple copies of same device are connected in parallel. So parallel means what? So this is D1. How many D1s are connected? Here D1 and the copy of another D1 we have to do here. And D2 and copy of another disk D2 and D2. That is another. Okay, so here the switching circuit determines which devices in any given group are function properly, whether D1 or D2, and how many devices we have to create the copies in each stage. So such devices at each stage, the result will increase the reliability. So at each stage, there are MI similar types of devices. So here 3, here 2, here 4. So DA is similar device of DA. So the probability of all devices MI have the malfunction is, probability is 1 minus Ri into MI. This is that very less, that is providing high probability for these devices. Okay, so here each stage, so this is stage 1, this is stage 2, this is stage 3, up to n stage. So each stage it becomes the probability, that is Ri means what? Ri, this is the reliability of your device DI, reliability of device DI. And pi RI means what? It is the reliability of your device over entire system. Okay. So each device, the cost is different. Okay. So what is MI? MI is the number of copies of device. So here 3, here 2, here 4. So totally 4 plus 3 plus 2, 9 copies. So that is MI, number of copy of device I. Okay. Suppose M1 is 3, then 3 copies used in D1. M2 is 2, 2 copies used in D2. And D3 equal to 4, M1, M2 equal to 4, 4 copies used in that device D3. So 1 minus RI. 1 minus RI is the not function properly. 1 minus RI will not function properly. Each device, first device is R1, second device R2. So if it is not function properly, then we can say 1 minus RI. And we have MI number of devices. So 1 minus overall the entire system is 1 minus RI power MI. RI power MI. This is the stage that is I will not function properly with respect to MI devices. I already said no, MI total number of devices. So with function properly, how can you find? This is the formula for not functioning devices. Overall system. So overall system with function properly devices, how can you find? 1 minus RI MI. So this is that stage I will function properly with the MI devices. 1 minus of 1 minus RI MI. It is the less reliability of switching. So we try to use devices duplication to maximize reliability, but this maximization should be considered along that cost. Okay. So along that cost. So overall cost of the system is C. Overall cost is C. And each device cost is what? C1, C2 up to C1, C2 up to Cn, each device cost. Suppose this one C1, stage 1, it is C2, it is C3. So the total cost of one stage is what? That is I equal to Ci Mi. M is I, we already know M is that total number of devices. Okay. And Ca is the, that is cost of the first stage 1. Okay, I is suppose stage 1, 1. Stage 2, it is C2, M2. Okay, so the overall stage reliability is, that is summation of I equal to number of devices N. So 1 to N Ci Mi less than or equal to overall cost C. Okay, that is the overall cost. Okay, so let's see how to solve this problem. So that is, I said no, the overall cost is maximize that problem. We have all the stage, total cost of all the stages, summation of I equal to 1 to N number of devices Ci into Mi It is less than or equal to total cost C for mi greater than equal to 1 and integer 1 to n. Okay. So here the pi I of mi denotes the reliability of stage I. That is pi I mi for all 1 less than or equal to I less than or equal to n. If the number of devices at any stage beyond some certain level, then also only the cost will increase, but the reliability would not be increased. Okay. So I said no. So RI means it is the reliability of the device. Suppose this is one stage 1, this is D1 and D2. So for this device reliability is RI. And the overall cost of that entire system is pi into RI. So each devices are, we are different stage 1, stage 2, stage 3. Each device having some reliability power R1, R2. So MI means number of copies of the device. If you have another one stage, so here if you have D2, 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 another one D2. So how many devices? Totally 5. So number of copies of device, that is M1 is 2, M2 equal to 3. And 1 minus Ri is will not function properly. 1 minus Ri of Mi means that is the stage I will not function properly with respect to Mi devices. If it is not functioning properly, then 1 minus of that is properly function with Mi device. Okay. And the overall cost is C. Each device cost is C1 to Cn. So the total cost of stage I at particular stage I 1 or 2 is Ci Mi. Okay, with respect to that is 1 minus of 1 minus Ri Mi. So here we have to think 3 important stages. One is total cost of the project stage. Total cost of the stage what? Stage 1, stage 2 up to stage n. So the total cost is C1, C2, C3 and number of devices is Mi. So it is summation 1 equal to n number. So 1 to n CAMI less than or equal to C. Okay, that is one function. Next one, the reliability of the stage. Total cost we are founded. Next one, reliability. So reliability means that is here we are going to find the upper bound. That is upper bound means what is the maximum number of copies we have to make in stage 1. What is the maximum number of copies we have to make in stage 2. Okay. So D1 equal to 1, 2, 3 up to 4. So pi I equal to Ci, C plus Ci minus summation of j equal to 1 to n Cj by Ci. It is the reliability finding formula. Okay. So the objective function of function is maximize pi I 1 less than or equal to I less than or equal to n pi I Mi. So it is subject to change. That is, it is depends on n number of devices. So CAMI less than or equal to the total cost. Okay. Now let's see with one example how this optimization problem is working. Okay. Suppose I said no. We have a number of devices D1, D2, D3, D4. Each device cost is C1, C2, C3, C4. And each device reliability is R1, R2, R3, R4. So the maximum reliability is 0.9. Okay. So what is that particular D1 stage 1 probability? Failure is 1 minus R1, that is 1 minus 0.9, 0.1 reliability. Suppose if we have 3 devices, 0.0001. Okay, it is the probability of failure. What is the success? That is 1 minus 1 minus 0.001. So that is the reliability, maximum reliability of 3 devices. Okay, that is 0.999. Okay. So let's see with one example. Suppose the problem is how to design a 3-stage system with the devices D1, D2, D3. So the cost is 30, 15, and 25. For D1 cost 30, D2 cost 15, and D3 cost 20. And the cost of the system is to be more than 105. That is total cost. Okay, cost of the system. And the reliability of each device is 0.9, 0.8, 0.5 respectively. So you must write a table. So the devices are D1, D2, D3, and the cost of the table is 30, 15, 20, and reliability of each system is 0.9, 0.8, 0.5. So UA is 233. How? UA means for this particular D1 cost is 30, RA is 0.9. How many devices we need backup? Okay. For this particular device, stage 2, D2, 15 cost, 0.8 reliability. What is that? How many devices we need? Okay. And this device, how many devices we need? Okay. So the overall cost is, this is the overall cost. So C1 plus C2 plus C3, the cost is 30 plus 15 plus 25, 65. It is the overall cost, sum of the cost. Okay. So what is the remaining cost? So C minus summation of CI. So the cost of the reliability, they are given 105. So 105 minus 65, the balance is 40. Balance is, that is output is 40. So now let's see the first device. How many devices need in the first one? So 40 by 30. 40 by 30, the answer is 1. Okay. So whenever the answer is come with 1, the formula of MI is sum C minus summation CI by CI plus 1. So that is we are founded previously. This one for all the problem. 40 by CI is this cost, first stage 1, 30. So 1 and plus 1. So plus 1 is what? 2. So the device stage 1, it records the number of device 2 and 2. So total cost is 40. Okay. C minus summation 15. So if you are divided, the balance may be 2. So 2 plus 1. Why it is 1 plus 1? 3. So the answer is 3 here. Next cost 20. So 40 by 20, these 2 plus 1, this one, that is 3. So that may be here. Okay. So finally, what happened that the overall cost or overall probability of how many devices we need Okay, how many devices you need, that is we are measured in that by using the formula. We are finding that reliability of each device. Okay, thank you.